You ever driven under one of those big old stone bridges and just looked up at that perfect arch? Well, it's not just there to look pretty. It's actually one of the smartest and most timeless designs in all of engineering. And today, we're going to find out why.
So what's the deal? Is it all for show? Just a little bit of old-fashioned style? Not even close. The real reason is a total masterclass in physics.
You see, that beautiful curve is really just an ingenious answer to a super old question. How in the world do you build something massive and strong using a material that can break pretty easily?
To really get why the arch is so brilliant, we first have to talk about the main material it was designed for, and that's stone.
Okay, so stone kind of has a superpower and a major weakness. If you squeeze it, what engineers call compression, it's unbelievably strong. But if you try to pull it apart or stretch it, that's tension, it just cracks and breaks. So the big puzzle was, how do you build a long bridge with something that hates being stretched?
Well, you get clever. You don't try to fight the stone's weakness. You design around it. And that is the absolute genius of the arch. It's all about redirecting forces.
Here's how it all goes down. A car drives over the bridge, right? That weight pushes straight down. Now, on a flat beam, that would cause it to bend and create that tension we talked about. But with an arch, that downward force gets channeled sideways along the curve. It gets turned into a squeezing force, compression, pushing all the stones tightly together and directing the load safely into the supports on the ground.
And this is not some new idea. This is an ancient solution, and we have some pretty amazing proof of just how incredibly well it works.
How well, you ask? Think about the Roman aqueducts. So many of them are still standing after 2,000 years, all because of this simple, powerful idea. It's an engineering marvel that has literally passed the test of time. So, if an arch bridge could talk, this is pretty much what it would say. It's not about muscling through a load with brute force. It's about cleverly using physics to send that load somewhere else. It takes a material's greatest weakness and makes it completely irrelevant. It's just a simple curve that absolutely changed the world.